This is Mr. Anderson for Kellogg Community College, and we're going to be talking about Section 5 of Chapter 5, Factoring Perfect Square Trinomials and the Difference of Squares. Now, I just want to say straight off the bat that recognizing perfect square trinomials isn't really a necessary skill, but it is a skill that will actually make your work a little bit quicker. Now, one of the ways to kind of help you with this is by making a square root chart on the side of your worksheet. Now, let me explain what that is. A square root chart just lists all the different roots that are available for our whole numbers. So, for example, list probably 1 through 10 to help you out with this. And then square those numbers, and those become the rootable numbers that you're going to be looking for. So 4 squared is 16, so therefore the square root of 16 is 4. And this is invaluable, especially as you start a test or a quiz where you have difference of squares or the perfect square trinomials. So if we take a look at the first example here, we'll notice that if we were using our factoring methods from the previous section, section 4, we would look for two numbers that would multiply to make 4 and add to make 4. Now that's a pretty easy combination because you're going to have x plus 2 and x plus 2. Because the only factors of 4 are 1 and 4 and 2 and 2. So this is the combination that makes this when FOILed. Now when we write our answer, we're going to put our x plus 2 quantity squared. Same thing goes here. What ways of 36 can we get to make our 12 in the middle? Now you'll notice that 36 can be, we know 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Well, the only way to make a negative 12 is to use negatives here for negative 6 and 6. So here we have our x minus 6, or rewritten in simplified form, x minus 6 quantity squared. So you'll notice that these two examples both have a situation where we have our answer as a binomial squared, or the two binomials are exactly the same. Will this work out here? Well, it absolutely will work out here, because the first thing we're going to do, and if you haven't seen the pattern yet, the old way is that you would take your 16 and multiply it by 9. And that would make 144. Now the question becomes is what is going to give me that middle term of 24? Now again, using the old way, listing all your factors of 144 is going to be very time consuming. And our purpose in this problem is to get to a place where we are making our work easier for ourselves and not harder. But just to show you the old way and how things are going to be, long and complicated, you'll notice that I'm still nowhere close to getting my two numbers to make the 24 in the middle. But I still have a long way to try here. I'm writing down my factors of 144, and it's going to take me a while to get to the correct combination. I already know what I'm looking for. I'm going to be looking for something where the two numbers are exactly the same. Now, on a test, you may not be that observant to find a problem in the needle in the haystack here, but just to show you how crazy this is going to get here, we're still working. There are still more factors to go. There's 9 and 16. There's 12 and 12. Now, this is the combination that's going to work. I had to go through all those factors to get it to work, and so if I split this up here, this becomes 12x, and this becomes 12x. And again, if you haven't seen the pattern here, you're probably, thinking like, man, this is taking a long time, and there is a shortcut. So, what number can I factor out of these two terms? Well, it looks like I can factor out a 4, and that will give me 4x plus 3. What can I factor out of these two terms? Well, here I can factor out a 3. Put a plus 3 because it's a positive 3, and that gives me 4x plus 3. Now as I put my terms that are alone together, whoops, I forgot my x there, plus 3. And then this is 4x plus 3. You'll notice that my answer is, like the problems up above it, 4x plus 3 quantity squared. So it took a long time to do that problem, a couple minutes. There is a shortcut. The shortcut is if the first term and the third term are in these rootable charts. Like you'll notice the first term is 16 and the second term is 9. What we can do is we can just make those into our first and last terms of our binomial. Now, since this middle term is a plus, that is going to give us this as a positive answer right there. So 4 plus 3 quantity squared is going to give us our answer. Now there is a check before you get to the point where you just commit to using the shortcut here by taking the root of 16 and the root of 9. The check is that if you take the square root of 16 and the square root of 9, which gives you 4 and 3, you should double those to see if, you should take 4 times 3 and double it to see if it makes 24, which it does. The actual formula of this shortcut is a squared plus 2ab plus b squared, which means that if your first term and last term are rootable, which means that you can take the square root of them, then doubling their roots should make the middle term. And if that is the case, then the problem is easily solvable. Now let's take a look at this last problem here, which you should, at the beginning of every one of these problems, check to see if there's a common factor you can remove. And in this case, there is. There is a 2x that we can remove, which makes our 25x squared minus, this is going to be 80x, and this is going to be 64. Now, to do this the old way, even I am probably not going to tackle this the old way, because multiplying 25 times 64 gives me an answer of 1600. So you'd have to factor 1600 and list all your factors until you got to the combination that works. Now, to give me negative 80 in the middle, the answer would be negative 40 and negative 40. And there would be a lot of factors to get down to this if I started building my tree. So what I'm going to do here is just take a look at how I can make this. See, this is going to be, I'm going to split that up here, negative 40x plus 64, and this is 25x squared. And I'm still going to then break this down here. It looks like I'm going to get really tight on room, so I'm sorry about trying to squeeze this in all on one page here. The number I can divide out of this here is going to be 5x, which gives me 5x minus 8 here. And then I'm going to factor out of here a negative 8, which is going to give me my 5x minus 8. And so my answer is going to be, I'm going to write it over here at the shortcut, 2x, the number we factored out at the beginning of the problem, right there, times the quantity of 5x minus 8 quantity squared, because it's going to be my 5x minus 8 inside a parenthesis and another 5x minus 8. Now, wow, could I have done this problem a lot quicker with a shortcut? Sure can. After I take my 2x out and I have my 25x squared minus 80x plus 64, I look at the square root of 25, which is 5. I look at the square root of 64, which is 8. And I look at the middle term in the middle. Is 5 times 8 times 2 equal to 80? It is. And since it's a middle term is negative, I put the negative there. And remember, you don't need to know the memory, you don't need to know the shortcut, but it sure did save a lot of work. Okay, the next piece is going to be to look at the bottom section here. This is actually a much quicker shortcut. This is the difference of squares. And in the difference of squares here, what we're going to do is take a look at how these patterns work out. Now, your square root chart is really handy here. The difference of squares means that if I have a squared minus b squared, that is the same thing as a plus b, a minus b. And the a plus b, a minus b is really important because you have to have opposites, so there's no middle term. You'll notice that there is no O or I cable here. This is just the F cable of the first terms multiplied by each other, and this is the L cable, which is the last terms multiplied by each other. So this problem, since both of these are rootable, the square root of 1 is 1, the square root of 16 is 4, this is going to be x plus 4, x minus 4. Same over here. The square root of 1 is 1, the square root of negative 4, or the square root of 4 is 2, so this becomes x plus 2, x minus 2. Now if you FOIL this out, you'll notice that your O and I cables are opposites, 2x and negative 2x. And that means you're going to only have two terms in your final answer. Let's look at this one here. This is going to be 3x plus 1, because the square root of 9 is 3. And this is going to be 3x, minus 1. This here is going to be 4x plus 5. And this is going to be 4x minus 5. Now, when you have powers that are bigger than just 2, the powers get cut in half. So this here would become x squared plus y to the 5th, and this would be x squared minus y to the 5th. Now, if this 5 wasn't, if this number, the second number, was like an even number, so let's say this was, y to the 6th and y to the 6th because we started with 12, then I could continue going from here because it's a difference of squares, but the odd power means I have to stop. On a side note, let's take a look at this before I do the final problem here. On the side note, if I have x squared plus 4, this is not factorable, this is prime. And the reason why this is prime is because it's not a difference of squares, it's the addition of squares. And if I took a look at this on the graph, this is a graph that would never cross the x-axis, so it has no solutions. So this is a prime problem, P-R-I-M-E, sorry for my bad handwriting there, and you wouldn't be able to finish it. So when I wanted to bring this up right before I did this problem here, because if I do the difference of squares, this is going to be x squared plus 1 and then x squared minus 1. But the x squared plus 1 cannot be broken down any further because it's the addition of squares, but this can be broken down further because it is x plus 1, x minus 1. As long as you have the difference of squares, you can keep going. This chain reaction problem will happen several times on your homework, so be aware of it. It will show up. And thanks for watching. Send me emails if you have any questions.